Okay, let's look at an example that you sort of need to figure out your type 1 and type 2 errors here. So we have an example here of a medical research, and we have a researcher that is interested in finding out whether this new medication changes the pulse rate of patients who take it. So suppose the mean pulse rate for the population under study is 82 beats per minute, BPM. Okay, and that the null hypothesis is that there is no change. Okay, remember the null is always the status quo in the patient's mean pulsive rate from this value. So our null is going to be that the mu is that the mean is 82. The alternate is that it's not 82. And they ask us to identify the decisions that would be right, the correct decisions, and the ones that would be type 1 and type 2 errors. Okay, so let's begin by this. So let's make a grid that sort of helps us to look at this idea. Okay, so this is our null over here, that the mean of the mean is no different, and that here is the alternate, is that the mean is different. So we can make two decisions. We could make that that the null is indeed true, or that the null is false. And then what decisions can we make about our null? We could either reject the null, or we could fail to reject the null. Okay, so let's start with our null being true. Okay, it's going to be the correct decision to not reject it, right? This would be the correct thing. This is the right thing. Not reject it. This would be the right thing to do. If the mean pulse rate of the population is actually 2 and the sample mean is not significantly different, so the sample is not really different from the population, we should do this. This is going to be one of those correct decisions. Okay. Now, if the null hypothesis in reality is true, it would be incorrect to reject it. So this would be a problem that I'm rejecting. I'm rejecting it, and this is my type 1 error. And what does constitute type 1 error is that I took my sample. Okay, and the mean pulse rate of the population of the patients is 82 beats per minute, but my sample is really different from those 82. Okay, so the sample looks different. Sample is really different. So I have this data that sort of helps me to reject, and I'm making here a type 1 error. Okay, now let's move over to the null being false. So if the null hypothesis is really false, okay, then what could I do here? So it would be really the correct decision to reject it. This would be a right thing to do. In other words, the mean pulse rate of the population is not really 82 beats per minute. My sample is significantly different from 82 per minute, and I believe that the medication really changes patients' pulse rate. Okay, that medication is really working. So my sample here, okay, this is a correct decision, and my sample supports that the mean of the sample is really truly different. Okay, I rejected. Fantastic. I did the correct. This is the correct decision to make in this case. All right. Now, if the null hypothesis is really false, okay, it is really false, but I failed to reject it. Okay, that would be over here. That would be that type 2 error that I could make. Okay, really, essentially, this business over here of type 2 error is sort of a missed opportunity kind of thing. It's a wasted opportunity. The population is really different from the 82 that I got in that sample. So the sample is different. Why is the sample different? Well, I've been giving them this medication. So this medication really makes a difference. and I didn't discover this difference, okay? I have failed to reject my null. I did not see that it's different, so I sort of wasted the opportunity. There was a difference, but my evidence did not show that difference, okay? So the sample did not show the difference. Okay, and this is my wasted opportunity. This is the type 2 error. The type 1 error is when my null was true and I rejected it. The sample appeared to be different, but it wasn't really different, and I rejected my true null. And over here, the type 2, the sample was really different, but it did not show it. There is a difference in reality, but it did not show. Okay, so we are missing an opportunity to start making this medication that might be helping people with their heart rate. Okay, so statistics do not prove anything absolutely. There are errors to be made. We hope that these areas are much larger, okay? But the only way to prove that something is 100% is to take the entire population. Now, again, you cannot take a medication and give it to the entire population. You're going to go bankrupt, and this is why we are sort of living with these type 1 and type 2 errors, and we try to minimize them, and we're going to talk furthermore how to minimize them in the future.